Hello everyone, this is the CircuitPython weekly meeting for Monday, August 3rd. It's the time of the week where we get together to talk about all things CircuitPython. I'm Dan and I'm sponsored by Adafruit to work on CircuitPython. CircuitPython is a version of Python designed to run on tiny computers called microcontrollers. CircuitPython development is primarily sponsored by Adafruit, so if you want to support Adafruit and CircuitPython, consider purchasing hardware from adafruit.com. This meeting is hosted on the Adafruit Discord server. You can join anytime by going to adafru.it/discord. We hold the meeting in the CircuitPython dev text channel and the CircuitPython voice channel. This meeting typically happens on Mondays at 2 p.m. U.S. Eastern Time, 11 a.m. Pacific Time, except when it coincides with the U.S. holiday. In the notes doc, which I'll talk about, there's a link to a calendar you can view online or add it to your favorite calendar app. We also send notifications about upcoming meetings via Discord. If you'd like to receive these notifications, ask us to add you to the @CircuitPythonistas Discord role. There's a shared notes document, a Google Doc, that accompanies the meeting and recording. You can contribute to this document before the meeting. The final notes document includes timestamps to go along with the video, so you can use the document to skip around and view the parts of the video that interest you most. The meeting tends to run 20 to 30 minutes these days. After each meeting, we post a link for the next meeting's notes document to the CircuitPython dev channel on the Adafruit Discord. Check the pinned messages to find the latest notes doc, so you can add your notes for the following meeting. If you wish to participate but cannot attend, you can leave hug reports and status updates in the document for us to read during the meeting. This meeting is held in 5 parts. I'll talk about each part as we get to them. So we'll start with community news, which is the first section, describing some news items of interest to people who are attending our meeting. Okay, and these come from the Python for Microcontrollers newsletter that Anne edits and that Adafruit publishes once a week. So first we'll start with the first item, which is the CircuitPython Day, which is an annual event run by Adafruit. It'll be August 21st, 2026. That's a Friday. To read what it says, it's that time of year. Adafruit has determined that August 21st, 2026 is the snakiest day of the year and designated it CircuitPython Day. Adafruit will have special shows and more throughout the day. Tag your projects, #CircuitPython Day 2026 on social media, and Adafruit will look to highlight them. Check out the schedule on the site as it'll change as more content is announced. So there's a link to an Adafruit blog entry, and that blog entry is dynamic. It'll change as things are added. So keep an eye on that. And we'll tell you what's going to be happening. And then our second and last item for today is about PicoGame, improving the microcontroller gaming performance of PicoGame. The ability to write Python on microcontrollers with the likes of MicroPython and later CircuitPython has made them much more accessible. Maker Class CZ brings that to game development with PicoGame. Like any good project, it started with a problem that needed solving. Put simply, the existing CircuitPython display code wasn't that fast for gaming. It does a lot of work in computing a pixel. The _stage module, which is simpler, wasn't flexible for Maker Class CZ's liking, so he built his own. And there's a link to a news item in Hackaday. We've edited a little bit what Hackaday said because it was a little bit inaccurate, but it sort of talks about the point. And the Discord user Smitka is Maker Class CZ, and there are active discussions on Discord about this. So search for those. It's very interesting, and Smitka is getting great performance out of this new addition to CircuitPython. So it is really good. So next, I'll talk to you about where these news items come from. They come from the Python on Microcontrollers weekly newsletter, There are archives. There's a link to the archives in the notes document. You could subscribe to this newsletter. As I said, it comes out on Mondays. We really are interested in things that you can send to us for doing the newsletter and puts it together. Email cpnews@adafruit.com with a link to content or your own content, whatever you'd like to see in the newsletter. We really appreciate your contributions. Your contributions really help the newsletter be great. Okay, next up is the state of CircuitPython, the libraries, and Blinka. This is a quantitative overview of the entire project. It gives us a chance to look at the health of the project separate from our status updates. We'll talk about the project overall and then separately discuss the CircuitPython core, libraries, and Blinka. So first up, overall, take a timestamp. Overall, in the past week, there were 28 pull requests merged by 12 authors and 6 reviewers. There were 21 issues closed by 6 people and 10 opened by 7 people. So a lot of activity in the past week. That's really great. And next up, we've got the CircuitPython core report. And if Scott's available, go ahead and tell us about that, Scott.
Yes. Sorry. For the core, we had 14 pull requests merged from 7 different authors. Weblate is a bot, so that's -1 there. Some new folks or infrequent contributors: Blitz City DIY, Spitka, and Jan and C. Darius are all infrequent, so thank you to them. We had 2 reviewers, you and myself, Dan. We have 15 open pull requests. Many of those are very old, to the point where we should probably just close them. But yeah, good stuff coming in. Issues-wise, we had 7 closed issues by 2 people and 7 opened by 5 people. So single digits number of people involved and keeping up with the influx, which is great. We have 764 total open issues. We track prioritization for Adafruit-funded folks using the milestone system. That is to say, we have 663 open long-term issues. If you would like to work on one of those, that means we're not going to be working on it, and we're happy to support you doing it. Our main focus is, 10.2 is our current stable release. There's no open issues there. That's been the case for a while. So it's looking quite stable. And then the next minor stable release will be 10.3 with 19 open issues. And that's come down significantly thanks to Dan's work on that. We have 0 issues not assigned to milestones, so we're keeping up with triage as well. And that's the numbers for the core.
Okay, thank you, Scott. Okay, next up, we'll talk about libraries, and we'll hear from Tim about that.
Yeah, thanks, Dan. This section will cover all of the CircuitPython libraries, which are hosted on GitHub under 2 different library bundles. We have the Adafruit library bundle, which has 396 libraries in it right now, coming up on 400. We have the community library bundle with 179 in that one, for a total right now of 575 different libraries that support various hardware and helpers on CircuitPython. Over the past week, we had a relatively busy week. 12 pull requests merged by 5 different authors. We had loads of names that were newer or less frequent or less familiar to my eye. So thanks this week for library PRs from Geary256, MadMX5, Hui Alex, and then GR Grant as well has been getting into library work a lot lately. So thanks to them. On the review side, we had 5 reviewers. Thanks to Scott, Dan, Tektrick, Brent, and myself for some reviews this week on libraries. Of the pull requests that were merged, the oldest one was 68 days, and then the newest ones, like usual, there was a handful of them down at 1 day old this week. Got some quick ones merged in. That leaves us right now with 39 pull requests open. The oldest one of those is a draft that's at 1446 days. The newest one is 1 day old. Issues-wise, over the past week, we had 11 issues closed by 4 people, 3 new issues opened up by 2 people, which leaves us with a lucky 777 open issues. There are 2 of those right now that are labeled good first issues. You can find those and all of the rest listed at circuitpython.org/contributing, which is the website where you should head if you are interested in getting involved in CircuitPython on the Python side of things. When you first load that page, circuitpython.org/contributing, you'll find a list of open PRs. You can look through that list, find something that's interesting to you or that you have the hardware for, click through to GitHub, and then you can leave a review for that PR. So that just entails looking over the code. You can look for things like syntax, spelling, logic, anything like that. If you do have the hardware, you can test it out, and then just leave a comment on GitHub letting us know how it went. What did you find when you looked it over? If you were able to test it out, how did that go? Once you get comfortable with that process, if you would like to join the review team that we have on Discord, we can work with you to add you to that so you get notifications and some other helpful tools. You can also start submitting some of your own PRs if you would like. If you click over to the Issues tab, you can look for either good first issues or you can filter on a couple of other labels as well. That's just a different navigation at the top of the same page. You click over to the Issues page. You have a similar looking list of links to GitHub, but these ones represent issues. They don't have a proposed change yet. There's no PR submitted, and you could come along and submit one if you'd like. We do have a Learn guide for contributing to CircuitPython using Git and GitHub. We also have folks who are happy to help out and who are around here on the Discord throughout the week. So if you are trying to get involved reviewing or submitting your own PRs, if you're having trouble with any part of the process, just come say hi on the Discord. Let us know what you're up to. We would love to help you out. We do want everyone to be able to contribute whatever way works best for them. And I will leave you with new and updated libraries for this week. On the new side, we have a new driver for the NAU 88L21 audio codec. Also an update to the Kinetic RGB library over in the community bundle, and then or that's a new one, excuse me. Kinetic RGB is a new one, and then update in the community bundle, the TLV 320 AIC 3204 audio codec has got some updates and improvements as well. And that is where we are at for libraries. Thanks.
Okay, thank you, Tim, Foamy Guy. Okay, next up we'll talk about Blinka. Blinka is our compatibility layer for CircuitPython on single board computers like Raspberry Pi. So what we're talking about is an emulation layer that supports running code written in CircuitPython using CircuitPython specific features, but it runs under regular Python known as CPython, and it'll run on, say, a Raspberry Pi, and it emulates the things that CircuitPython does. So you can write the same code and run it either on a real CircuitPython board or run it under Linux. So in the past week, there have been 2 pull requests merged by 2 people. Giryu256 is a less heard from contributor. There are now 13 open pull requests for Blinka right now. In the past week, there were 3 issues closed by 2 people and no new issues opened. There are currently 78 open issues, and we've got now support 174 boards under Blinka, which is quite a few. All right, that's it for the state of CircuitPython, the libraries, and Blinka, and then we'll move on to Hug Reports. This is a chance to highlight folks in the CircuitPython community and beyond for doing awesome things. I'll start, and we'll go down the list of Hug Reports alphabetically. If you're text only or missing the meeting, I'll just read your notes when I get to them in the list. So I'll start, and I'd like to thank GR Grant for fixing a whole bunch of library bugs and continuing to work on issues about the library in the past several weeks. Thank you very much. Okay, next up is Tim, Foamy Guy.
Right, I have Hug Reports this week thanks to IonU2, or Darth Paul, in parentheses on their name in Discord, who gave me a tip about some newer 1.5 volt Lion AA and AAA batteries when I was griping about older rechargeable batteries not holding the same voltage. So small thing, but a huge thing in my life. So thanks to them for the tip on that. Thanks to Relic SE for looking over the I2S duplex functionality and some discussions around it, as well as it looks like a fix that was submitted for that too. And then lastly for me, thanks to Smitka for venturing into 3D support for Pico Game.
Okay, thank you. And next up is Scott Tanut.
Hello, a hug report for me for the mods and helpers on Discord. For some reason, Discord has not gotten their arms around or preventing this crypto image spam that we've been getting on our server and a number of other servers. So just shout out to folks who are pinging us and deleting this spam. I'm hoping Discord's going to get on top of that soon.
All right, thank you, Scott. All right, that's it for hug reports. Our next section is status updates. This is our time to tell folks what we're up to individually. Like before, I'll start and we'll go through the list alphabetically. You can talk about what you've been up to in the past week, and if you want to, what you're going to be doing in the next week. And if there's a discussion that comes up that seems too long, we can move it to in the weeds section. So first of all, I'll say in the past week, I worked on updating the embed TLS it's a submodule in CircuitPython, but it's a whole another library that's for doing TLS and encryption and things like that. And we were on version 2 something, and now we're on version 4.2.0. The Espressive port has its own version of RP of embed TLS, but we use our own version for the Raspberry Pi, that is the RP2 XXX boards. So this was specifically to fix a specific problem that a user had, but we should have been updated quite a while ago because there are bug fixes and new features. So we were several years behind. And besides that, I'm going to starting to work on diagnosing some problems with the BLE workflow, which hasn't really worked very well for a while. And that is it for me. And next up is Tim.
All right. Last week, the support for I2S duplex was merged into the core. The driver for the NAU 88L21 was added to the library bundle, which were both things that I needed in order to finish up the guide that I'm working on, which is for the Teenage Engineering EP2350 Ting, running CircuitPython, and I am working on wrapping that guide up today and recording a couple videos to finish it off. The next couple of things I want to look into are the PR that is submitted in the core for USB audio, the added support for stereo, and then I also have some audio effects that I have been working on. The flanger is the first one up that I need to submit a PR for as well. So that is what I will be up to this week. Thanks.
All right. Thank you, Tim. Okay. And next up and last is Scott.
Hello. I've been working on the hardware in the loop stuff. I got the Python stack, so this is like Pi USB, Pi serial stuff. Able to flash the ESP32C61 over USB IP to the P4, which is cool. But we are pivoting a little bit to work on Zephyr on the LM20. So I pushed all of the code for the hardware in the loop stuff. If folks look under Adafruit, there's some Python packages there that do Pi serial, Pi USB via USB IP and stuff. So that's where that's living until we get back to it. So we're going to focus on the NRF54 LM20A. This is going to be kind of our flagship chip for the Zephyr push, or for the Zephyr port, which is going to be super cool. So my focus this week is getting back into Zephyr Brain, and then also working on BLE GAT, which is like the client and server characteristic stuff in BLE that is like foundational to being able to use BLE. So that's my focus this week, and hope to get a PR out either this week or the end of next week for GAT support.
Okay, thank you, Scott. So that's it for status updates. And our next section is In the Weeds, which where we have somewhat longer form discussions about particular topics. Often we don't have anything here, but Bob G., also known as GR Grant on GitHub, as a topic he'd like to discuss about sort of the issue, the questions of using the Adafruit register library and the costs of using it in libraries, um, and whether there might be some ways of making it smaller or making the code footprint smaller. So it makes writing libraries easier. It also makes libraries larger. So there's a trade-off there in its current form. So Bob, would you like to go ahead and discuss what's going on? And
Sure. Can you hear me okay?
yep, just fine.
Okay. So yeah, just briefly, when I when I retired 10 years ago from the university, I said I'm getting into open source for a side thing to do in retirement, and I just got around to it, 6 or 8 months ago. So it took me long enough, but I've been enjoying this. So first of all, hello to everyone, and glad to meet you all online here. Um, I will start out by saying I'm not sure there's anything that can be done, but I just want to kind of throw this stuff out here. I was looking at an issue that I think maybe we should just even close on Temp 117, issue 11, where Lady Ada had said, can you guys help get the size down? Because somebody was complaining they couldn't run it on an early non-ESP32, maybe M0, I don't know, QT Py. And of course, that has very little memory. So, it's problematic. So for anyone that doesn't have the dock up, I looked at 6 of Adafruit's temperature, slash other sensor libraries, and 4 of them all did less than 5K, but Temp 117 and BMP 5XX did in the 13, 14K size, and that was surprising to me. And so subsequently to a lot of the work, I've looked carefully at the libraries, and kudos to Scott for the I2C one and Tim for the later SPI register accessor version. I don't know that there's a lot that can be done to make them more compact, to tell you the truth. And I personally agree that, it's better to read things well than to have space. So, that might be, the way to just leave things. I did want to bring up, though, a couple things at the end, just and open it for you guys to say if there's anything to be done or should be done. I noticed that in Scott's unary structure, it allocates the byte array actually each time it is accessed. And Temp 117 does that access every time you read the temperature, which seems like it might be churn if we don't want to do memory optimization necessarily, but want just better code. I throw that out there. And then if we were trying to squeeze things down at the biggest extreme, and I think this won't be possible, should we have two different kinds, which would be possible, of ones in the I'm stepping on my tongue. The places where it's allocated as accessed and then garbage collected for little used registers, but place where it's accessed once because it's in the init only for less used. That might be too complicated. We might not want to do it. And then maybe too dangerous is to have a class-wide buffer and then we spend it once. So anyway, I tried to be brief and I did a core dump. So that's my thoughts.
All right, thank you.
Yeah.
Yeah.
Yeah, thanks, Bob, for looking into this. I really do appreciate it. I think that generally memory use of libraries is something that we don't look a lot into. We don't track a lot. And I think I'm actually very afraid that this is going to get much, much worse. LLM generation, where we can just generate accessors for every possible register. So I would be curious to know, like, if I2C register is bringing in 9K, where is that? How is that 9K spread throughout? Like, is that just code size? Is it error message strings? Is it variable names? Like, what exactly is driving that up? I think my main complaint, if we don't use something like register, is that you have a lot of code that's not common, right? Like the accessor functions of like read a byte, write a byte, is like redone for every single library, but that doesn't mean that we couldn't factor that out as well. I do like the structure of register. Yeah, I think it's. I think there's a little bit more of like, why is register so big? In terms of buffers, I could see changing register to use a class-wide buffer. The only problem with that is you have to assume that you're single-threaded or single accesses, which for now is okay.
And that's what I didn't understand well enough, whether that would be possible. But I don't know if that would gain much. And I might just throw together a copy with it done that way and see what the difference is. I mean, that would be interesting to know. But anyway,
sizing it might be a little trickier. Like figuring out how big you actually need that for all different register types that are going to reuse it.
Right.
I agree that like it's not ideal to allocate the buffer every time you access it. Although each individual thing is going to be pretty quick because we do keep track of like where the last thing we found is. Like it will incur more garbage collections when we're doing the like allocate it once. I think maybe there's a middle ground of like you don't allocate the byte array until you do it once. And then once you've done it once, you hold on to it. But that's extra code. I don't know. It's tricky because like one of my arguments for register was also that like you are sharing accessor code across a lot of different accessors. Then, like the code itself gets shared. Like the function bodies get shared across accessors of the same type.
And I mostly just wanted to raise it for people's awareness. Truth be told, the more I looked into it, Temp 117 isn't only increased because of, and I didn't look at BMP5XX because I said, well, it's similar, maybe. But Temp 117, it's not just the register accessors, but they do, they do bring a bit in because there's a ton of registers. So there, it's a lot of instances that it spins up. And then it, in addition, has all of those, as it's called CV. I can't remember. It's that class where you can create the various named things for the timings and stuff like that, and that adds some. And so, I mean, there's more than one thing on Temp 117, and it's more complicated. It's got more routines. So there's, but anyway.
The other thing that I thought about, which would I think would be, sorry, Dan, do you want to go?
I was just going to say, so the CV stuff, that was when this library first came out, I was kind of also bothered by how much space it took. And I tried to figure out how to do some of the binding kind of stuff, like the CV kind of stuff at compile time, basically. And I could not do that because Python just didn't have the facilities. That's why I said in Discord, for instance, like if this were a set of macros in C, which is what the Arduino Adafruit Bus IO library is, a lot of the stuff sort of disappears when the compiler turns it into just shifts and bit masking, but we don't see that here, and so I think it would be interesting to sort of like take a library like that and disable various parts of it, like take out the actual accessor code or take out the actual CV code and make it non-functional and just see how much space there is when it gets loaded and see like where is the biggest cost. I'm less worried about buffer RAM stuff because we always have to deal with that for anything, but I'm more worried about code space. I mean, I think these values include these are the actual GC meminfo values, right? This is
that
not
is
just,
correct.
Yeah. So the Adafruit register library itself is actually fairly large because it has a lot of different cases in it, and that itself just takes a lot of space. So if you made that a skeleton of itself, how much how large would the actual templates in Team Library be? Like where exactly
Right.
is the storage being spent? But
Right.
short of like, and I think also we could think about some kind of macro preprocessor, but I haven't, as I mentioned, I haven't found anything. There's something called PyMacro 3, but it's like 8 years old and it hasn't been worked on since then.
The thing that I've been thinking about in this vein for saving memory of imported code is like JavaScript. I think primarily does this, what called tree shaking, right? So what you do is you start at your root, like your code.py, and you figure out all the code that might be executed, and anything that isn't actually going to be executed, you just delete, right? Like, so that's like, oh, I've got 3 different types of registers that are in this imported file, but in practice, I'm only using 2 of them, right? Like, at load time, we say like, let's delete that third one because we're not going to need it.
So maybe refactoring a library to do import on demand. Like
That's a way to do it manually. Yeah.
yeah. There's actually in Python 3.16 or something, I don't know, it's coming up. They're going to have lazy imports as a supported feature, and I don't know if that's going to be at all useful or not.
Right.
I think that may be just per module and not pieces of modules, but that it's worth looking at that at least. So anyway, yeah, I think this is it's very interesting, and I also think that is there some because we can now ask LLMs to do certain things, we could also make the library generation be a little more complicated, but also maybe have it be more efficient in some way. But I don't. There isn't a standard for that kind of thing yet, like a macro preprocessor. Okay, I've said my piece.
And I wasn't actually asking for anything to change necessarily. I was basically throwing this out there. So I'm happy with this. And as I said before, if I were writing a driver, I'd want to use the register library. I mean, why, try to figure out bit twiddling yourself if you can just hand it to something and let it do it reliably every time. So kudos to you guys.
I think sometimes a low-hanging fruit for this is like we do have the const mechanic where you can say like these static variables that I have at the top, I don't actually want to export those as names. You can do then underscore and then do const of the value, and MPYs will fold that together. That can be a quick win, especially if like the person who put the library in also uses register, and so register is like just using those const values. Like if you don't actually need the const values, you could actually, or yeah, the const values, you could use that like special const construct to like drop the memory used by the name itself.
But I think in a lot of libraries we're already doing that. So
I should actually just take a peek at the 10.17.
yeah, I think it has more. I saw it as more having to do with the CV value stuff, but it also is just true that the Adafruit register library itself is rather large.
Yeah. I mean, we could always split it further if we needed.
Yeah. We could make it invisibly have conditionally imported submodules.
There is some const stuff, but some stuff that hasn't been made const.
Mm.
I'm looking at like device ID. I mean, that's pretty small potatoes. Oh yeah, the CV.
Yeah, the CV stuff is there's a lot of CV stuff, and those are like dictionaries, and so I think figuring out what the footprint of the various different kinds of components in would say, well, what is the largest thing that's worth tackling here, and what is premature optimization?
The proxy for that is looking at the MPY file as well.
Yeah,
I mean, you're not going to capture how big the libraries are, but your MPY is a reasonable approximation of what the file itself will look like in memory.
right. So if you just deleted some, you could make the library be non-functional, but still compile it with MPY and then see how big it is. So just comment out pieces of it, like get rid of all the CV stuff and see how much that footprint is. or how big is the temp 117 MPY itself, not including Adafruit register? How big is Adafruit register? That kind
Do
of
we
thing.
keep document strings?
No, no,
Okay, for MPYs, but do we keep it in memory for? We don't
no,
keep it in memory at
no.
all.
I checked. I
Okay.
checked this recently because somebody asked, and I kind of
Okay.
reconfirmed that no, it gets thrown away.
Okay.
It gets thrown away in
Yeah.
parsing even or something. So
Okay.
my MicroPython was very interested in reducing that, and we do what they do.
Yeah. The native sim stuff. What was it? Who was it looking at? TechTrick was looking at instrumenting all of our libraries using Zephyr native sim so that we could keep track of the memory footprint. So that's a way to do memory loads on your Linux computer without having to do it on a device, and it should be pretty faithful to how big the size is and
That's
stuff.
an interesting, yeah.
Because it's like that's why it's 32-bit. Is like you get all the same memory properties that way. If you need a quicker way to look at it, Bob.
I apologize. I was just going to put it in the Discord. I had to drop off for 2 minutes because somebody was at our gate and to see my wife. So I missed about 2 minutes of what you said. And if you gave me some tips, I would definitely like them
Okay,
in any
so
way.
it'll be in the recording. So
Okay, sounds good. I will go
okay,
back and listen to the recording. So yeah, I just had to buzz someone in the gate, so I had to pick up my phone, which was what I was on Discord with. So
okay, all right. Well,
No
good. Well,
worries.
yeah, that's fine. Okay, no
The
problem.
the main thing is if you want to do testing on your computer itself, you could use Zephyr Native Sim
huh.
and set it up to load this driver.
Hmm.
You may not be able to run it without doing some fancy stuff to fake the I squared Z, but you should at least be able to like import everything
Oh, that's
and
interesting.
measure. You'd be able to measure memory footprint, and you could add instrumentation to stuff there
Oh wow.
because it's
I,
32-bit, so it's going to give you a good representation of everything in memory.
I will check that out.
Yeah, and feel free to ping me. I'm happy to help you get it set up. I'm
Okay.
getting us
Thank
into
you.
a
Thank
Zephyr
you. Yeah.
world.
Okay, well, thank you, Bob, for bringing this up. I think it's worth bringing up. As,
What's that?
as all right, so we'll wrap up. Right now, I'll take a timestamp for wrapping up. And just the next meeting will be next Monday, same time, um, August 10th, 2026. And we'll see you then. Okay. Bye bye, everybody.